Alright guys, I'm going to try and record a short video to show you how to set up and solve word problems for today. Don't worry, I know it's a big packet, we're not doing the whole thing. We're just going to look at the first 2 pages today. So for systems of word problems, they're going to give you 2 different scenarios, and that's how you'll set up the 2 word problems. For example, on number 1, they're telling us first here that the sum of 2 different numbers is 30. So we know that sum means to add. You can pick whatever variables you want. I'm just going to use x and y. So x plus y should equal 30. And then the next thing it tells us is that their difference, so same 2 numbers, the difference, which we know is subtraction, is going to be 12. So then we're going to do x minus y equals 12. And then once you have your system set up, you can solve it using any method that you want. For this one, I would probably use elimination, because I noticed that when I add straight down, my y's will cancel. So adding straight down, x plus x is going to give me 2x. My positive y and my negative y will cancel. And then adding my numbers, 30 plus 12 is 42. So then when I divide both sides by 2, we'll get that x is 21. And then once we know x is 21, I just plug it in. 21 plus y equals 30, or 21 minus y equals 12. Or I just think about it, and I know that if one number is 21 and I have to add to 30, the other one has to be 9. Alright, number 2, you'd set up and solve the same way. So just x plus y, and then the other one would be x minus y. Once you get to 3 and 4, it gets a little bit different because now they're adding more in. So for 3, we've got the difference between 2 numbers is 9. That's simple enough. We just saw it in the last one. Difference is subtraction. So x minus y equals 9. Then it tells me the first number plus twice the other number. So right there is where it's going to change a little bit. Instead of just doing x plus y like we did in number 1, they're telling me it's the first number plus twice the second number, so plus 2y equals 27. And then again, we can solve it using whatever method we want. I could use elimination. So if I notice my x's are the same, but the variables won't cancel yet, I just switch one of the signs, so make that negative, positive, negative. And then solve it just like we solved number 1. So adding straight down, x's will cancel. Y plus 2y will give us 3y. And then 27 minus 9 will give us 18. And then we get our answer for y is going to be 6. Once I know what y is, I can plug it into either of the equations and get my answer for x. So I can either plug it in here. 2 times 6 gives me 12. And then I can subtract 12 from 27. Or I can plug it in here. X minus 6 equals 9. And then I add the 6 to both sides. Either way, we get that x is 15. Or if you wanted to on this one, you could also use substitution. So I'll show you that method as well. If I use substitution, I see for both of these I could easily get x by itself. So what I'm going to do at the top, I'm going to add y to both sides to get x by itself. So now I've changed my top equation. It becomes x equals 9 plus y. And then we're going to take this and plug it in for x at the bottom. So instead of x, we're going to put 9 plus y. And then we keep going with the rest of the equation. Plus 2y equals 27. Combine my like terms. All right, and you'll see you'll get the same answer, so it's up to you which method you want to use. So 9 plus 3y equals 27. And then we just solve for y. So subtract 9 from both sides. We get 3y equals 18, and we still get that y equals 6. And then once we have our y, we just come back up here. I know that x equals 9 plus y, so x equals 9 plus 6. We still get that x equals 15. So it's up to you which method you want to use. All right, and then same idea here with number 5. The sum of two numbers is 20. So again, we're just going to take x plus y equals 20. And then for our next one, the difference, so now I'm subtracting between 3 times the first number. So I know I'm going to take 3x, difference is subtraction, and then here where we've got twice the second, that's going to be 2y is 40. And then again, you can solve it using either method. And so I can use elimination. If I see I have a positive y and a negative y, so if I multiply this whole top equation times 2, now my top equation becomes 2x plus 2y equals 40. My bottom equation doesn't change. 3x minus 2y equals 40. And then we're going to add them up. So my y's here will cancel. Adding straight down, I get 5y equals 80. And then we just have to divide 80 by 5. We do that, we get that our y is 15. And then we can plug that answer in wherever we want. I would probably just go back to this original one because it's a lot easier looking. No multiplication involved, which means we won't have to divide. So I know x plus y, now we know y is 15, equals 20. And so then we just subtract the 15 from both sides and we'll get x equals 5. So try out 2, 4, and 6. That same kind of way, set up the two equations, and then you can choose elimination or substitution. I think elimination's a little easier on these top problems here, but substitution works as well. And then when we get to that second page, it's going to be the same kind of thing. As you read the problems, you'll set them up as you read. But this time we're going to bring money in, so we'll end up having some decimals as we're setting them up. So as I go across, the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. I'm going to write it out just like that. So 3 boxes of envelopes, I just use E for envelopes, and 4 boxes of notebook paper, so N for notebook paper, is $13.25. So there's my first equation. My second one comes from that second sentence. 2 boxes of envelopes, so that'll be 2E, and 6 boxes of notebook paper cost $17. And then once we have the 2 equations, you could solve with whatever method you want. Looking at them, since they all have numbers in front, I would probably just use elimination. We're trying to find the cost of each. So since none of my numbers match up, I'm going to take this whole top equation and multiply it times 2. So now we're going to have 6E 8N equals 2650. And we're going to do the same thing with the bottom equation, but now I'm going to multiply the whole bottom equation times 3, because I'm going to get rid of E for both of these. So times 3 will give me 6E, 18N, oops, sorry, wrong number, and then 51. Now that my E's match up, just pick one of the equations and make everything negative. I'm going to do the top because then I don't have to deal with negative variables, even though it'll give me the same answer. So as we add down, negative 6E and positive 6E cancel. Negative 8N and positive 18 will give me 10N. And then the negative 2650 and the 51 is going to give me 2450. And then if I just divide both of those sides by 10, I'll get my answer for notebooks. So my notebooks are going to cost $2.45 each. And then I just pick any of the equations to plug it into. So going back over to an original here, 2E plus, I'm going to do 6 times that, 245, so that's going to give me 1470 equals $17. Subtract my 1470 from both sides, so 17 minus 1470 gives me 23, or 2.3, I'm sorry. And then when I divide that by 2, you can tell I'm really not feeling very well today. Once I divide 2.3 by 2, I get that the envelopes are going to be $1.15. All right, same thing with number 8 here. The cost of 12 oranges and 7 apples is $5.36. Cost of 8 oranges and 5 apples is $3.68. You can solve using whatever method you want. I would use, again, just elimination on this one, so that I don't have to deal with subtracting and dividing. You can pick whichever variable you want to get rid of. So if I look here, let's just get rid of the O's again. So multiply the whole top by 8, whole bottom by 12. I'm going to run out of time on my recording here. All right, so whole top by 8, 96 O, 56A equals 4288. And then on the bottom, 96O plus 60A equals 164.16, and then we just pick one to make negative add them up and solve for our variables.